So hello everyone, good day. So now we will be moving forward to the next type of reaction, which is for a second order reaction. This time we'll be doing the bimolecular type second order reaction. So A plus B forming into products. So again, writing the rate equation, negative RA so we have negative RA is equals to negative TCA PT. It should be capital because capital TCAD. So it is directly proportional or equal to KC CA and CB. Anong KCA times K times CB? It is because, excuse me, because ang disappearance ni A magdepende po siya sa disappearance ni B. This is also equal to negative RB, which is also equals to negative DCB dt. Okay, so if you want to find the concentration of B at any time, so we will be using this one, DCB over dt. Since again we assume that A is our limiting reactant, so we will be using that one. So now, using the equation, this one, so we need to find a relationship because again here we have CA time CA and CB, so we have three variables, so we cannot directly do the separation of variables. So we need to find a relationship between CB and CA, and that is in terms of conversion. So using the chemical reaction, this one, so let me just insert a table again, TBCA table for change after before change after there. So before change after. So we have A, B, then products. As you all know, with wala tayong pakialam sa products. Let's leave it blank. So this is A plus B forming two products. So for A we have what? We start with CaO, right? CaO, Ca0, and for B we start with CbO. And then sa change we have CaOXA. This is negative because again we assume that our A is the limiting factor. So the after or the change is equals to that one. This one is equals to that one. Add, right? And then if we add, and I mean this is all equal to the after is also the same saying as this is CA and this one is CB. So we could say that that one, and for this one that. So we could say that CA is equals to CAO minus CAOXA and CB is equals to CBO AOXA. So we substitute this to here. So we have for CA we have this. Let's put some parentheses. And for CB we have this. Right? That. But now again we are still at three variables CA, T, and XA. So remember the relationship between XA and CA. We have this one times B of XA cut. That one is equals to negative D CA, right? So using that one, so using this relationship, so we substitute it to the equation. P lang negative, kaya negative this A man. So we now have this equation. So we have CAO dXA over dt is equals to KCAO. Yes. So we could factor out the CAO here. So if factor out the not CCAO, this should be 1 and this is deleted. Nah. And then we cancel the CAO. Cancel natin yung CAO. So we are left with this. So we have now this. So if we use variable separable, pwede na. Kaya we have only XA, T, and XA and T as our uh, independent variable. independent dependent variables. Meanwhile, CBO and CAO are constant, so using separation of variables, so we will get cut, paste, pt, this one. So as you can see here, we have this equation. Then applying the integration, same goes here. So at t0, our conversion is 0. At time, anytime, our conversion is xa, right? So what we have here is type of an equation. This side, we have this. We could integrate this using the partial fraction decomposition. This one is the same. So using partial fraction decomposition for the left hand side, left hand of side of the equation. But so kayo na bahala mag um, partial fraction decomposition yan.